We said, stop treating land as a single-use surface, raise the solar panels, keep the farm, restore the land, produce the energy, same footprint, multiple outputs. Once again, the same philosophy running in the opposite direction. If solar was about what we build above ground, this is about what we refuse to build below it. Data centers are the physical backbone of the internet. Every search, every stream, every transaction, every AI query runs through one. And right now, almost all of them sit on the surface of the Earth. They consume land, they consume enormous amounts of water for cooling, and they consume roughly the same amount of energy managing their own heat as they do actually running their operations. That last number is worth sitting with. Approximately 40% of a data center's total energy consumption goes toward cooling. Not computing, not storage, not connectivity, just managing the heat the building generates. That is not a small inefficiency. That is nearly half the energy bill of one of the fastest growing infrastructure categories on Earth, doing nothing except keeping the facility from destroying itself. Now go underground. 10 to 15 meters below the surface, ambient ground temperature stabilizes at between 10 and 15 degrees Celsius, globally. Regardless of whether you are in Norway or Nigeria, that stable, cool temperature is not a geological accident. It is a free cooling resource that exists everywhere on Earth, continuously, without any energy input whatsoever. It has never been systematically used for data infrastructure. Underground ambient temperature alone does not solve the full cooling problem at scale. Concentrated server heat is intense enough to require active airflow. This is where the design gets genuinely elegant. Build a wind tunnel into the underground structure. The natural pressure differential between underground air and surface air creates continuous airflow through the facility. That airflow carries heat out passively. No mechanical chillers, no cooling towers, no water consumption for evaporative cooling, no additional energy load managing heat. The geology and the physics do the work. The engineering just needs to stop ignoring them. What does eliminating 40% of energy consumption do for a data center operator? It changes the entire economic model. Smaller energy contracts, smaller carbon footprint, smaller operating cost, permanently for the life of the facility. It also changes the siting logic entirely. Currently, data centers cluster near cheap energy sources and cold climates because both reduce cooling costs. Underground facilities with wind tunnel design can go anywhere there is bedrock. That matters for the regions currently excluded from data infrastructure. Large parts of Africa, Central Asia, and South America have geology perfectly suited for underground data centers and almost no local data infrastructure above ground. Now add the closed loop. Remember the elevated solar canopy. Raise the panels above ground. Farm underneath. Restore degraded soil. The solar feeds whatever is connected to it. Put the underground data center directly below the elevated solar installation. The panels above generate energy. The facility below consumes it. The cooling is handled by the ground and the wind tunnel passively. You have just built a largely self-contained energy and compute installation on a single surface footprint. The land above is still usable. The energy is generated on site. The cooling costs almost nothing. The surface land remains productive. The subsurface becomes productive. The solar output goes further because the facility it feeds needs dramatically less energy for cooling. Every element amplifies the others. This is the same design logic as part 1. Stop treating any layer of the available environment as single-use or wasted space. Above ground, surface, and subsurface are 3 separate productive layers on the same footprint. So why aren't data centers being built underground? The answers follow a familiar pattern. The people with capital to build them were trained on surface construction. Surface construction is what financing models are built around. Underground construction has higher upfront engineering costs, and the organizations making siting decisions are optimizing for speed of deployment, not lifetime operating efficiency. The 40% cooling cost is baked in as normal. Normal is the most powerful force in infrastructure development, not physics, not economics, not engineering possibility. What was done before is what gets done again, until the need for an alternative becomes impossible to ignore. The cooling industry serving data centers is substantial. Chillers, cooling towers, cooling management systems, cooling energy contracts. That 40% is not just a cost to the data center operator, it is revenue to someone else. Judge by fruits. The current design produces a permanent cooling cost, a permanent energy premium, a permanent water consumption load, and a permanent constraint on where data infrastructure can viably be built. The underground wind tunnel design eliminates most of that permanently. The fruits of that design serve the operator, the grid, the local water supply, and the regions currently excluded from data infrastructure simultaneously. First we said, raise the panels off the ground. Now we say, put the data center under it. Same philosophy, same logic. One design decision changes what the entire footprint produces. Above the surface, elevated solar and productive land simultaneously. Below the surface, data infrastructure cooled by geology and wind. Between them, a closed energy loop that makes both more efficient than either would be alone. The technology exists. The geology exists everywhere. The engineering is not speculative. The economic case is stronger than the current model when measured across the lifetime of the facility. The only thing that doesn't exist yet is the decision to treat above ground and below ground as part of the same design problem instead of two separate industries that never talk to each other. That is not a technical failure. That is an imagination failure. And imagination failures are the ones that are hardest to forgive.